Okay, now we're gonna move into some early pre-calculus. We're gonna move a little ways into pre-calculus. Give you a huge head start. Okay. Okay, so we're just gonna make a table for y equals x squared. Okay, with these x values. And the x values you get, and I've already asked you to do this, and as expected, I did it all correctly. Okay, so there it is. Okay, now, I'm gonna ask you. Make a graph. I want you to put -2 here. And 2 here. And we're gonna put 4 up here. And if you look at what I did here, my -2 is this far on the left, my 2 is this far on the right, so 0 is, as it should be, halfway between -2 and 2. I probably don't need to tell you that. Try to get a good looking graph here. Better than what I'm gonna get, because mine's already a little crooked. Okay, so with this much guidance, what I saw you do was you divided this interval from 0 to 2.5 and said there's 1. And you divide the interval from 0 to -2.5 and said there's -1. Now, my -1 looks like it's a little closer to -2 than it is to 0. And that's partly because of the angle with the board and partly because I'm not being all that careful. So it probably should be more like about here, but we'll live with it as it is. Then you got 4 here, and what I saw you do was you divided this interval in half and got 2. Then you divide this interval in half and you get 1. And then midpoint of this interval will be 3. And you could understand that pretty completely. And I did comment, well, okay, now you're gonna need a -1/2 and a 1/2. So what did you do? Put a -1/2 here, halfway between 0 and 1. And you put up 1/2 here. Or -1/2, halfway between 0 and -1. So we're gonna understand that that's 1/2. Okay, now you're gonna need a 1/4 up here. On the y-axis. Well, we're going to continue dividing intervals in half. So I'm going to divide the interval from 0 to 1 on the y-axis in half. And I understand that that's a half. Then I divide that in half. And I get pretty accurate 1/4. Okay. So now we're going to plot the points. So go ahead, let's see what you do plotting these points. Okay, so I was watching over your shoulder because I love to see a master at work. You did a very nice job. Okay. Now, when I plot these, of course, you located them accurately, but just for demonstration, because I'm going to use this video very likely. But for calculus students who still aren't doing it right. Okay. So my point -2, 4 is the intersection, is at the intersection of the line in this vertical dotted line that I just drew. Giving you a little extra. Okay, this is x equals -2. So this is a line x equals -2, meaning that every point on this line has an x coordinate of -2. Well, that should be pretty clear. Any point in this line, x coordinate is going to be -2. And also this line includes all the points that have x coordinate -2. includes all the points. Put the word in there, because a lot of people don't read all that, right? And people will say, well, didn't you just say that? No, this statement is different than this statement. That'll be clear on why, but I'm not going to belabor it too much right now. Okay, now what's this line? Okay, this horizontal line here. Could you label that line with its equation? Okay, so I just asked, what's the equation of this line? And got an instant answer. That's y equals 4. So if the intersection of the line x equals -2 and y equals 4, we get the point that we can label. Didn't ask you to label them, but no doubt you could have. Okay. And maybe you actually did. Okay, so we got -2, 4. Then, using similar strategy, we could label this line x equals -1. And this line y equals 1. And we get a point here. Of course, we could label the line x equals 1. And of course, we got the line x equals 2 here. And the line x equals 1/2. And the line x equals -1/2. And then we'll do the line. Not doing a very good job of that, but we get the idea. For y equals 1/4. And now we can locate all of our points. Now, of course, we got the point 0, 0. Well, the line x equals 0 is just the y-axis. I mean, if that's x equals -1/2, that's x equals 1/2. It's better be x equals 0. And the x-coordinate of every point on this line is 0. That'll make things more visible. I'll put these points in blue. Right. Now, I labeled this one, I could label all the rest of them, but I'm not going to go to that trouble. I'll label a couple of them. Not, I'm going to say one. Okay, so there we have it. Now, these lines, x equals -2, x equals -1, and so forth. These are vertical projections. So what if we're going to use terminology? We'll define it. Okay, so these are all vertical projection lines. I'm going to draw arrows to all of them. And these are horizontal projection lines. Notice there are only 3 of them, 4 if you include the x-axis. And there are 7 vertical projection lines if you include the y-axis. Okay. The domain of the function as it exists is the graph this is 7 points. because I don't automatically draw a curve. Now I'm gonna, right now, this table gives you the graph of a function. And the graph consists of 7 points. Here's a little stuff at the end there. Put the x coordinate on the set. -2, -1, -1/2, and so forth, right? And we call this the domain of the function. Okay, so let's give this thing a name. Y equals x squared. Is the, I'm going to call it the toolkit squaring function. Sometimes it's what's called the basic squaring function, which I've called it for years. Open Math uses toolkit, and it's a really good adjective. Okay, I kind of like it. But once in a while I regress. Okay, this set here is the domain. Now, we talked about domain and range, so you're familiar with it, okay? It's the domain of the function. In this case, it's the toolkit squaring function. And maybe it's a little hard to read. This is the domain of the function as represented by the table. Okay, the range of the function and I'm going to say this a little more. Represented by the table and the blue dots. Okay, there's a function, it's a perfectly good function. Its domain consists of the x values 2, -2, -1, -1/2, 0, 1/2, 1, 2. And the range is the set of y values. And the y values are 0, 1/4, 1, and 4. I don't list 1/4, 1, and 4 twice, even though they occurred twice on the table, because this is a set. Okay. 1 is in the set. Whether it's this one or this one, it's in the set. And the set is just defined by what's in it, not how many times everything is in it. And so that's domain and range. Now, I use the terminology and Open Math doesn't. And Open Math just defines a function as a graph that you get by punching numbers into a calculator. which I think is evil. Okay? You don't know the arithmetic, you don't know why the numbers are what they are, you don't understand the function. Now, the numbers are easy this time, so, yeah. It's kind of harmless in this case, but when you get to the exponential function, which we're gonna look at in a minute, it's different. Now, I do a couple more definitions. Now I'm gonna extend the function. Okay? For the yellow curve, the domain is what? I'm gonna ask you, see if you know, because you've apparently done a good bit of stuff. Okay. Now, the domain of the yellow curve, now, one thing you did that you've been taught to do is I noticed that you put arrows on this thing, okay? There are no arrows on my functions. Now, in your function, there are arrows. And you correctly told me what the domain would be if there are arrows. It go 0 to infinity, right? But my yellow curve, I'm sorry. The range, well, the domain would be negative infinity to infinity. Okay, but for the yellow curve, which doesn't have any arrows on it. Okay, and let's go ahead and make sure we understand that we've got a closed yellow dot, kind of obscures a little bit of the blue dot, so that -2 is included, and so is 2, and I think you know that. Okay, the domain then would be the interval from -2 to 2. Are you familiar with the bracket notation? Yeah, the bracket means, first of all, the -2 means all x values from -2 to 2. And the closed bracket means you include -2 and you include 2. And then the range, well, the domain includes all the x values. Okay, and the x values corresponding to points in this curve include everything from -2 to 2. The y values for the curve go from 0 up to 4 and include 0 and 4. Since 0, 0 is included, automatically we do that, and since we have closed dots at the ends, 4 is also included, so the range goes from 0 to 4. Okay. Now, I call this the extended basic function. We've extended from the dots to a curve, but we haven't gone outside of the domain of the table. Now, this is just my personal terminology at this point. Domain range, yeah. But when I go to extended, toolkit. Query function, it might be a little hard to read. That's what we've got here. Now, you wanted to put arrows on it. So I'm okay with that. Okay. Now we put arrows on the thing. And I'll just kind of draw a red curve that goes right on top of the yellow curve. It's offset a little bit because I don't want to wipe out all the yellow. And why is my camera? Blame thing. My camera suddenly zoomed back so nobody can read anything. I say it often, but I love the camera for its clarity. It's a great camera. But why does it have to go do that every once in a while? I didn't ask it to zoom. I don't have any way of telling it not to. Okay, well, there it is, and I think the message here is clear. And then I'm gonna call this the complete basic squaring function. My own personal terminology is the whole blame thing, the whole blame toolkit squaring function, okay? But we'll call it complete because people think that's more polite. Okay, so complete. I use the word basic and I'll use toolkit. Complete toolkit squaring function is now in red. And its domain is think before you write is the interval from negative infinity to infinity. Why? Because I can put any real number at all into this formula and get a y value. Okay, so x could be any real number between negative infinity and infinity. Now, infinity isn't a number, neither is negative infinity. Infinity is something you approach. You never get there. So infinity is not included. Infinity is not even a number. It's something you approach. Okay, so I use open parentheses. Okay, in the range. Think. Right down what we wrote down before. Careful and deliberate. Keep telling us what. The range is everything from 0 to infinity, including 0. And you can't include infinity, so you use the open parentheses. All right. Now, real quickly. Now look at y equals 2 to the x, the basic exponential function. The toolkit. Y equals 2 to the x. And I'm going to use the same x values. We're going to run into a problem with that. So we're going to have to eliminate a couple of them because we're going to stick with x values that you can calculate by yourself without the aid of a calculator. And write the number down exactly. Okay. So go ahead and fill in the table. Just see what we get, and then I'll make a couple quick comments. Let you go on to the assignment. Okay, no, you did great. Got 1/4 here. 1. And you wrote down something like the square root of 2. Actually, it would be 1 over the square root of 2 because it's a negative exponent, right? We know that. Okay, but what I say earlier, you got to be able to write this. You got to be able to write this in decimal form. You got to be able to locate it exactly on a number line. Okay, can you tell me where square root of 2 is in a number line? Can you do it exactly? Actually, it's possible. You just draw the square with sides exactly one. And then by the Pythagorean theorem, this is one, and this is one, this is square root of 2. So on a number line, you got, let's say 1 is here. Okay, well, I'll go ahead and draw the square here, the square root of 2, and then you just take this arc down here, and right there is a square root. Okay. Now, I think you could do that. I think you could understand that. I think I'll give you a compass and straight edge you could construct it. But now open math said, oh, just plug it into your calculator. You don't understand what it is, why it is, but just go ahead and plug it into your calculator and say, bull feathers. We're not going to use it. Okay. We don't need it. This is all we need, because if you draw a graph, I'm going to slop this down here. We're out of time. Here's -2. Here's 2. Here's -1. Here's 1. Up here's 4. Here's 2. Here's 1. Here's 3. Here's 1/2, and here's 1/4. Just what we did before. Except we don't need -1/2 and 1/2. And we don't need -1/2 and 1/2. See what this graph looks like. This graph here, then it's here, and here, and here, and here, and you can draw a nice graceful curve through this. Okay, and you don't need the -1/2 and the 1/2. Now you did need it to get the shape of your parabola, of your square. Okay, because you have to see how it behaves when it gets down near 0. Okay, people tend to make it kind of sharp here. You know, that doesn't have a nice smooth shape. When most people graph it without the -1/2 and 1/2. Try to honestly go through -1/2, 1/4, 1/2, 1/4 on the square graph. You get a nice smooth curve. Okay. Get a nice smooth curve here, and you don't even need the 1/2 and -1/2. Not only that, but you want to put -1/2 and 1/2 in here. Go ahead. I can come up here and over here and estimate 2 to the 1/2 is 2 to the -1/2. So. Well, that's more than you have time to do since you're 3 minutes over time. But your assignment is going to be the full set of toolkit functions. Open math is going to tell you, use your calculator. Graph these things without a calculator, just from -2 to 2, using just these numbers. And if one of these numbers doesn't work, throw it out. If you can't construct it or make it exact, don't do it. Okay, leave it off. And then, okay, yeah, answer the open math questions. If you got to use a calculator, okay, but be sure you can construct these graphs by hand using your own arithmetic, not your calculator. Then, of course, I know you know how to use a calculator. Oops. Wait a minute.